the recording. Right, question 4. The logs question, express 2 log base 3 of x minus log base 3 of x plus 4 as a single logarithm. Okay, so we've got to apply some of our laws of logarithms at some point. Remember the laws of logarithms, the adding and subtracting ones, require you to have the same coefficient in front. Preferably 1. We write them on our poster as 1 log base a of x plus 1 log base a of y is log base a of xy. So I think the first thing to do is to stop having a 2 hanging around at the front of this. And you're going to get 1 mark for doing that. So that's log base 3 of x squared minus log base 3 of x plus 4. Can I, it's not affected many people, but a thing to stress for a few people, if anything, exaggerate your notation here. So you see this little base here, make sure that that remains as being a subscript number. Don't allow that to creep up so it looks like log of 3x. Make sure it stays as a little number underneath. So we've used our laws of logs for that one. The second law of logarithm says that when you subtract, you divide. So log base 3 of x squared over x plus 4. And that's it. That is it expressed as a single logarithm for 2 marks to begin with. Now we're into part 2. Hence solve the equation. And the equation you see is the same left-hand side, but it's equal to 2. So the same left-hand side is equal to 2. Remember, again, it's on your poster, the thing that says that log base a of b equals c means the same as a to the c equals b. Do you remember that rearrangement? And we're going to have to use this because we've got it as a logarithm equals something. So we need to either write 2 in terms of log base 3 or get rid of the logs by rearranging it. So that's our model that we're looking at. This says that a to the c equals b. So 3 to the 2 equals b. So we get to that point. 3 to the 2 is often equal to 9. You may remember that from such maths things as squaring stuff. And if we multiply both sides by x plus 4, you get to that line. Oh, it's heading for a quadratic equation, isn't it? We've got 9x plus 36 is x squared, so 0 would be x squared minus 9x minus 36. Oh, if only that would factorise. It does. 36 is 12 times 3. So this factorises as being x minus 12 times x plus 3, which gives us x values as 12 and as minus 3. And as we write that, we think, oh, that's gone well. And then we think, oh, hang on, this was one of these logs questions. I remember something about logs. In logs, oh yeah, in logs, the number that you put into the log has to be greater than 0, doesn't it? It's not valid for a negative number, because if you try and do that on your calculator, you do log of a minus number, then it says math error. So the final twist to this is to think that 12 bit, that's fine, because 12 is positive and 12 plus 4 is definitely positive. But minus 3, although it would work in that one, because that would give us a positive number there. Minus 3 in that one, 2 log base 3 and minus 3 isn't valid. So x must be greater than 0, therefore x is 12 is our only acceptable answer at the very end of that. And that was 2 marks and then 4 marks. That's maths.